So A is a line passing through this point 3,02 and the B, point B, with coordinates 4, 3, 0. Is that right?
Yes.
Then it says determine the parametric equations for L1 and L2. So also for L2 passes through points B, which is this one, the same point B, 4, 3, 0, and point C. And point C has got coordinates 8, 1, minus 1. Those are the points. I hope you can see that this is in 3 dimensions, is it? Yeah, this is in 3 dimensions. Then it says find the parametric equation for the lines. Is that right? What does an equation do? Sorry? What does an equation do? An equation of a line. It gives you a set of points which lie on the line, isn't it? Yeah. Like normal, if you got an equation like y is equals to 2x plus 1 on a 2-dimension plane, this line is nothing other than a set of points which lie on the line. Is that right? So now, if we are looking at something like this, we want an equation which passes through these points, and that line is L1. So we just say L1. The parametric equation will be: you take coordinates of a point, that any point on that line x, y, z in 3 dimensions is going to be equals to let me say 3, 0, 2 plus a parameter lambda or whatever. But now, what you get between these 2 points? You get the direction of the line. But the direction of the line, we can get it in terms as a vector from A to B. So now we can have that. Let's take vector A to B. We must give that vector. What's that vector? It's 4 minus 3, which is 1, and 0 minus 3 minus 0, which is 3, and it's 2, or minus 2. Then we have that line is going to run in that direction, will contain this point, then we'll have exactly something like 1, 3, minus 2. Then we're done. That's the equation. I hope you understand what I'm saying here. You get a point, the line will pass through these 2 points. But if you fix 1 point as some kind of, in brackets, initial point, then you've got to get the direction of the line. The direction of the line is given by the vector which runs from one vector to another. So I could have chosen this point, and then maybe you might find that this one comes out slightly, but it will be the opposite vector anyway. If I take the vector BA, let's say I'm running from this point to that point, it will be the opposite vector, but the line will be exactly the same line. No, it doesn't really strictly matter. Yeah. So now I think we can now try to what? Or let's try to answer the second question. Maybe let's get the second line.
So I can, so that one is my answer. I can use.
Yeah, this is the parametric equation.
But why have you made use of lambda?
Oh, lambda is a real number. I forgot to write. It could be t, it could be lambda, is a real number. So in other words, what I'm saying now, I can choose lambda and calculate, I get a point on the line. Choose another lambda, I calculate, I get a point on the line. So that way, I will generate the whole line. Yeah. Is that making sense? Okay. Which one do you normally prefer to use? T?
Yeah,
Okay, okay, okay. I saw in the assignment there's used lambda. That's how the child used lambda. There's nothing like that in your assignment. Lambda. Is there? Is T? Where did that? Maybe I read the wrong book, man.
So say
Okay, let's use T then for your comfort. But it really doesn't matter, né? If you find it as lambda somewhere or as alpha, you mustn't get surprised what's going on now.
so say I go on and simplify that one. X is equals to 3 plus T. Then Y is equals to. It's the same thing.
Yeah, sometimes people can write this thing this way. You can write it X is equal to 3 plus T. Y is equal to 3 plus that. It's exactly the same thing. It's exactly the same thing. That's what you do when you've got a system of questions, you've got infinite solutions. Those infinite solutions more or less are numbers which are on the same line. Yeah. Is that right? Okay. So now let's take this one. This one will be X, Y, Z. In terms of working, how you lay out your solutions, please look at the solutions which you get after the assignment. Sometimes you work according to the example in the book, but you find that your lecturer maybe presents those are two options you've got. But normally, I think maybe it's preferable to write maybe in the language which is more your lecturer is used to, in terms of how you put out. If you want to put this thing as 3 parametric equations, X, Y, and Z with T's, if that's what the assignment does, you can do that. It's not a problem, as long as you understand how you can switch from one side to another. Yeah. So now here we get again T. We get our direction vector. Can you get our direction vector then? 4 minus 4 minus 2 minus 1. And then our T again is a parameter from the real numbers. Now, it is said now, determine whether L1 and L2 are mutually perpendicular. Then the question is, that's the question you should ask yourself. Do I know when two lines are mutually perpendicular? If they are mutually perpendicular, it will mean that the vectors involved are mutually perpendicular. But then, do we know when you can say two vectors are mutually perpendicular? But do you understand what does it mean to say two lines are mutually perpendicular to each other? They what? They form a right angle. Good. They form a right angle. Now we must, with that says, we must have a criteria which tells us that two vectors are forming a right angle. And you don't know that criteria. If you don't know it, then you haven't read. It has something to do with the scalar product. The scalar product is equal to 0. So now we've got two vectors. There are two vectors. 1, 3, minus 2. We're saying, oh, dot 4 minus 2 minus 1. Who is saying, oh, what's happening?
I remember now.
Oh, I see, said the blind man sitting at the corner of a round table. Okay, right, you remember now. Good,
Yeah.
good that you remember. So you see, those are the little questions. When you get a question, you ask yourself those little questions. Do I know this? When is it? What's the criteria for this? For that? Then, like you remembered because of the discussion was going on. Is that right? So if you start that discussion with yourself, listen to me. You start the discussion with yourself. Now you must really talk to yourself. Yeah. So what we get there? We say 4 multiplied by 1 plus 3 multiplied by minus 2. Let me correct that. It's not visible. multiplied by minus 2 plus minus 2 multiplied by minus 1. Please check how I'm writing my brackets there. You never write something like this, like plus followed by minus. Now, one of them must be in brackets. That's right. Why I'm talking about that, because I've seen this kind of, I don't know what I want to call it. I think I'll use a derogative word. Let me leave it. Okay, so this is 4 minus 6 plus 2, which is 0. Then you can say L1 is perpendicular to L2. That's how sometimes we use that notation to say it's perpendicular to L. Okay, are you satisfied with that?
Yes.
Are you sure?
Yeah.
Okay. So what else is related to that? This 6.2 part A and B, 6.1 part A and B is done. Then it says, does the point 8, 4 minus 5 lie on the line? There is the line given there. Show all your working. Now, I will not start with that line. Let me start with another line. The line given is 7x minus 3y plus 4z equals to 8. And the question is, let's call this line L, little l. Then we're saying 8, 4, minus 5 this point. We're being asked, does it belong to L? I'm just using that as kind of my short notation of saying, does this one belong to that? You know this sign of a set. Yeah, because line is a set of points, so is this a member of that set? I put a question mark there. I'm lazy to write a long sentence there. So now, when does a point belong to a line? How do you know that this point belongs to a line?
When you equate it and it gives you the same answer, like equals to 8. Like if I equate that x, y, z, if I say
If you equate x, y, z,
if I replace that,
or if you substitute it there. Okay, if you substitute it there. The right terminology, you can say the point belongs to the line if it satisfies the line. Satisfies the line. This is a fancy kind of language. You must try to translate it into your understanding. What does it mean for a point to satisfy a line? What does it mean?
Meaning that if I take it and I substitute whatever I'm supposed to substitute, in the end I'm supposed to get that equation, that line.
It means when I substitute the coordinates of the point into the equation of the line, I must get a true statement. A true statement. In other words, the left-hand side must be equal to the right-hand side. If I get a false statement, then the point does not belong to the line. Do you understand what I'm saying?
Yes.
Let's check with this one. Y, simple line. Y equal to 2x plus 1. Checking. Is 4, 5 on this line? What do? You substitute 5 for y. Equals. You don't do this. I'm trying to make a shortcut there, which is not right. It's not right to shortcut sometimes. Let's say left-hand side is what? Is equals to y. Then there, which means equals to 5. Then right-hand side, that's how we do it. Please, you handle these things separately. Right-hand side is 2x plus 1. But x equals to 4. Then 2 times 2 plus, 2 times 4 plus 1 equals to 9. Then the right hand side is not equal to the left hand side. Therefore, does not belong to the line. You can say now 4,5 is not on the line y, 2x plus 1. Do you see what I'm doing here? I'm working, doing the calculation of numbers, and I write a statement replying. You understand what I'm saying? Don't just numbers, underline. No. You must communicate your solution. Are we together? That's very important. So now what do we do here? We want to check whether this point satisfies that line. So what do you do now? Angle your left hand side, which is 7x minus 3y plus 4z. Now we know our x is that. So then we see this must be equal to 7 brackets 8 minus 3 brackets 4, are we together? Plus 4 brackets minus 5. Then this is what? 56 minus 12 minus 20.
No, it's equals to 8.
I'm not sure. Tell me what.
Yeah, it's 28. 20, yeah.
Is it 8 or?
24.
This is 56 minus 30, 32. And the answer is 24. And our right hand side is equals to 8. So right hand side not equals to left hand side. Therefore 8, 4 minus 5 is not on the given line. In this case, we are dealing with only one line here. We know what we are talking about. This is given line. But if there are two lines, then you must actually specify which line you are talking about, and that must make a difference. Otherwise, you confuse the person who's dealing with the work. My sister, are you fine? What's your name? Tenya. Okay. Why not writing on your desk, Tenya? It's not comfortable.
It's fine.
Oh, okay. Yes, my sister, they are fine. Are you all right? This side? Guys, they're fine. Okay. Are you all right? G8. G8. What's your name? Wei. Okay. Let me say, I'm not going to record this. So guys, can you say this is discussion done, or you still have some more questions too?
The last one.
The very, very last one?
Yeah.
Okay.
No.
The very last one says, 6.3 says, the line L passes through P. No, this is a new line. A new line L passes through P1 and P2. Determine the point of intersection with the XY plane. This is an interesting one. I hope we're going to manage to do it. So we've got a line L. This line passes through P1. Let's get the coordinates there. The line, the 2, 4, minus 1, brackets, and these are the points on the line. And P2 equals to 5, 0, 7, and that. Okay, so now he says we've got what we're given. You are given an x, y plane. This is some kind of 3 dimension. If you look at this, oh, that's not clear. That's not clear. If we look at this, could say that is on XY plane. If we look on this one, can say that is on YZ plane, isn't it? Then if we look on this side, that is on ZX plane. So more or less that's kind of a thing. If you look at that corner of the room, that's more or less where we're looking at them. Then the other things are behind and the other things are underneath the floor. Are we there? Okay. So behind that corner is this side. Behind that black hole, sorry, behind that corner is we've got this and that side and that behind. And then the rest is at the bottom this side. So now the question is, this line which passes through this point, does it have a point somewhere on this plane? That's the question. So then let's get the equation of the line. Let's get the equation of the line. So let's get P. We get the vector P1, P2. P1, P2. What's the vector? It's 3 minus 4, 8. Now, the equation of that line, L, will be X, Y, Z equals to, let's take it from P1, 0, 7 plus T brackets 3 T minus 4, 8, that. And our T, it's very important, always you must specify that kind of condition, that T is from the real numbers.
So I can.
I used both points. I used the P1 as the starting point. Then this is a vector between the two.
Right, but why are you using P2? Can I use P1?
Yeah, you can use P1. Yeah, you can. Okay. So now, what we need to do now. Remember, on the XY plane, a point, just an arbitrary point on the XY plane, has got X, Y, and a 0. Any point is like that. All together. Okay. So now we need to take this kind of a point and substitute it in the equation. If we get a true statement which has no contradiction, nothing, then we can say that line passes through the plane. But if you get a contradiction, then it will tell us that no, it doesn't pass through the plane. Let's see whether we get a contradiction. If we don't understand what I mean by contradiction, then we will see what happens. Whatever. So let's take a point and put it here and say x, y, 0. That is our, am I right? There's something which is a bit funny for me here. Okay, let's do this. Let's do this. There's something which is just clicking in my head, which is funny. Right. Let's say, let's take it this way. Maybe okay, let's take it exactly the way we say that x equals 2. I'm taking it as a 5 plus 3t. And take your y is equals to 0 plus minus minus 14. Minus 4t. And then z equals to 7 plus 8t. Huh? Then is z equal to 0? Check that. If you now say z is equal to 0, we can now conclude that t is equal to what? Minus 7 over 8. All together? Oh, sorry. Minus 7 over 8, ne? Minus, are you sure? Minus 7 over 8. Now, that is what t is. Now what must happen now? We take this 7 and put let's take the 7 over t and put it there. It will give us that y equals to minus 4 times minus 4 times minus 7 over 8. What does that give us? 7 over 2. And then for x, x equals to 5 plus minus 21 over 8, which is equal to 40 over 8 minus 21 over 8. What is that? 19 over 8. I think the point belongs to the line. I mean, the line cuts the x-axis. For that kind of t, will have a point on the line, because if you put t here, check if you put t here, it's going to be z with 0. So this line would be expected to cut the axis at 19 over 8, comma 7 over 2 and at 0. Yeah. Now, how could you have got a contradiction? Somewhere here, we could have, I think somewhere there, we would have got something like what?
From there, I can say that it intersects at 19 over 8, 17 over 2, and 0.
Yeah.
That's what you're saying.
Yeah, that's what I'm saying. That's it. I'll check that because this I need to double check this thing. But I'll check this thing. I'll verify with you on the. Yeah. But because normally when it doesn't belong, it will give you a kind of a contradiction. Or the other thing, this is what you can do. This is the direction vector. Yes or no?
Yes.
If that is the direction vector, that is the direction vector. No, but it cannot help us because if it, oh yes, if it does direction vector, let's see. I'm thinking that if that is the direction vector, what we can do, let's take, look at this, look at what I'm doing there. Look at what I'm doing. Let's take a vector which is 3 minus 4 and a 0. Do you see that this vector is on the xy, and this vector is somewhere in the 3 dimension. Now, if we were to know that these 2 or this vector points to the plane inside the line is cut the frame, what can we do? We can calculate the angle between the 2 vectors. You understand what I'm saying? You can calculate the angle between the 2 vectors. If the angle is 0, what does it mean? It will mean that the line is parallel to the plane, so it will never cut. But if angle is not 0, then somewhere it will cut the. Now I'm looking at the vector on the plane and the vector which is, and in this case I chose it carefully. Check how I chose it. Is 3 on the x-axis. 1, 2, 3 on the x-axis. In the direction of x minus 4, in the direction of y minus 4. 1, 2, 3, 4. So this vector is pointing somewhere there. All together. Then the other one, this other vector, is exactly the same thing, but it goes 8, which means somewhere here I'll go vertically. I'll go 1, 2, 3, 4, 5, 6, 7, 8. Then the vector will be somewhere like that. Do you understand? So, but what we are seeing there, what does it tell? What is it telling you? It's true. This point, this line cuts the line somewhere. So actually, I think I've given there 2 methods. One, this one can just give you that they are parallel. They are not parallel, but this one gives you the exact point where the line cuts the horizontal plane. Is it clear? The 2 explanations. Okay. That's one thing I just came up in my mind that's what we can do. Look at the vectors, take this vector right on the plane, take this vector which is going to the 3-dimensional space, check whether they are parallel. Yeah. But if they were parallel without doing the sketch, if they were parallel, it will mean that this vector is a multiple of that one. Do you understand what I'm saying? If you can multiply this vector and get that one, or multiply that one and get that one, then we'll say they are parallel. But can you find a number which can multiply 0 here to get 8? No. So I think I've got 3 methods now in that discussion which confirms that this line is not parallel to the XY plane. Am I making myself clear? Okay. I hope. Do you see? I'm not trying to be funny, but do you see one problem? It's possible to look at it from different angles. That also is one thing which you must try to train yourself. We look at the problem, you suggest a solution. You might also be thinking, is there any other way I can look at this, or is there another beautiful way I can present this thing? Then you do it exactly that way. Yeah. Good. I think this was a rich kind of a question. I think it was really, yeah. But I would like to see, this is an assignment.
No, it's an exam paper.
It's an example. I wish I could see how they solved it, they suggested the solution. Yeah. No, yeah, I'll try to find it maybe, if I can find it. All right, so can we, that number 6, can we say we've done it? We can conclude it? Is that fine?
Continuation.
Or is continuation of the same problem?
Yeah.
Of the same problem, exactly the same problem?
Not exactly the same.
Oh, not exactly the same problem. Okay, so now we are dealing with number 7. Okay, let's see what number 7 says. Let's take it number 7. Number 7 says, determine an equation of a plane through 1, 1, 1 and is parallel to x minus 3y minus 2z minus 4. In this one, you are given an equation. What is equation? X minus 3y minus 2z minus 4 equals to 0. So this is a plane, eh? Right? This is a plane. Then you need another plane which passes through the point 1, 1, 1, and that plane is ax plus b y plus cz plus d, ne? Plus d equals to 0. So our d here is playing the same role like in mx plus c. So now if you want an equation parallel to that one, you keep what? Your gradient, then you substitute the point on that line. So in this case, we can now keep this part playing the role of that. Then we say, what's that? X minus 3y minus 2z plus d, which is our known, which you don't, equals to 0. So now we know that it passes through this, which means now that point must satisfy this equation. So now in the second step, we now substitute that by minus 3, 1 minus 2, 1 plus d. So this becomes a new equation with an unknown, which is d. Then we solve for d. I think, what do you get here? Minus 5, ne? No, I mean this minus 5. 5, then plus 4, plus 1. I mean, what I've underlined is like I put it in brackets, ne? Yeah. So I put that in brackets, it's minus 5. Then 4, then equals to 4 plus d equals to, also minus 4 plus d equals to 0. Then we say therefore d is equals to 4. Now our equation, therefore the required equation is all that part, plus a new d, which is our 4, then which is x minus 3y minus 2z equals, plus 4 equals to 0. Then we're done. Is that right? Yeah. So I hope that is clear, and then that's going to help us. Huh? Okay, thanks for that. I think it was also a kind of a nice discussion. So if you've got that's what I'll do. Sometimes people go to another method or even a different approach altogether. Just share it, then that enriches people of options which they can take. Because sometimes you find a situation which actually favors one option over the other. Then you proceed. Then that way you learn more. Anyway. Okay. So is that all what you wanted in that part of the question? Or that's question 7? Or we should continue to that one? Hello? So let's say maybe that's all what we wanted there. Come again?
No, I'm asking if anybody else has a question.
Anybody else has a question? You want to continue the same question or different question?
Question.
You're code that one. Okay. So if you're calling that one, let's maybe stop that discussion then say thank you for listening. Then let's continue in the next presentation.